Battery Basics – Understanding Electricity. This video explains how energy flows from a battery to power a motor or other high-voltage component. Electricity is the flow of free electrons between atoms. The simplified model of an atom has a positively charged center called the nucleus and negatively charged electrons orbiting around it. Things with opposite charges attract each other, while things with the same charge repel each other. So, the positive nucleus of the atom will attract negative electrons, but if the electrons get too close to each other, they will push each other away. In most solid metals, atoms and their electrons remain relatively still, but in certain metals, like copper, the electrons have the ability to move around. In metals, the positive nuclei stay in the same place, preserving the structure of the metal, but the electrons can drift around from atom to atom. Since the negatively charged electrons repel each other, when one atom moves to another atom, it will move the electron next to it, and so on. For example, say you have a wire that is only one atom thick. If you force an electron to jump to the second atom in line, the electrons will all push each other down the line. This is the flow of electricity, or current. How do we measure electric current? We use amperes to measure current. An amp refers to the number of electrons that are flowing per second through something that conducts electricity. 1 ampere is the equivalent of 6.24 times 10 to the power of 18 electrons flowing per second, or 1 coulomb. So electrical current refers to the amount of electron flow. As an analogy, we can think of water running through a pipe. An electric circuit is a closed loop where current can flow around. Voltage is the difference in electrical potential energy per unit of charge between 2 points. We can define potential energy as the ability to do work. Work could mean moving something, heating something, powering a motor, etc. Voltage acts like a pushing force, forcing electrons to start moving around, which creates an electrical current. Using our water analogy, we can think of voltage as pressure. When we increase the pressure, we increase the flow. What creates voltage in a battery? Voltage is created by a chemical reaction in the battery. The negatively charged side of the battery will push electrons away from it because electrons are negatively charged, and the electrons are attracted to the positive side of the battery, allowing everything to flow in a complete circuit. Voltage is what pushes the free electrons around the circuit, creating a current. More voltage will result in more pressure, which results in more current that can flow. For example, if we increase the voltage, more current can flow to the motor, spinning it faster. We can measure current through a circuit just like we can measure the flow of water through a pipe. To do this, we use a device called a multimeter. Voltage can exist without current, just like pressure can exist in a pipe, and only when we release the pressure by opening the tap will the water flow. Voltage and volts are different things. Voltage is the pressure, and the volt is the unit we measure the pressure with. We can measure volts with the voltmeter. What then are watts? We discussed that amperes refers to the number of electrons, or coulombs, flowing per second, and volts is the amount of energy transferred for each coulomb of charge that flows. We measure power in units of joules per second, also known as watts. Electrical power is the product of volts times current, in units of watts. Another way to explain it, watts equals voltage times current. In our example, a battery of 1 volt turns on a light bulb through a current of 1 amp, which equals 1 watt. So, following this formula, if you increase the voltage, in this case by replacing the battery with one of higher voltage, or if you increase the current, the power, or watts of the system, increases accordingly. A fuse is a safety device that melts and breaks an electric circuit if the current exceeds a specified safe level. Fuses are rated to handle a certain amount of amps, and if too much current flows in the circuit, it will burn out and break the circuit. A relay is another way to interrupt a circuit. A relay is an electrically operated switch. Relays ensure complete electrical isolation between the controlling and the controlled circuit. In an EV, the relay switch is operated through the low-voltage 12-volt system. When a relay is open, no current can flow. When the relay is closed, the current can flow uninterrupted. A battery is a device that is used to store energy for later use when we need it. The energy is stored as chemical energy that can be converted to electrical energy. A battery is what provides the pushing force, which will allow the electrons to flow through a circuit. The battery can only push the electrons through a circuit for a limited amount of time, and just how much time depends on how much energy is stored inside the battery and how much is demanded by the load. A load is any component that requires electricity to operate. Most battery cells in an EV battery are similar to regular household batteries. The cell will have a positive end called a cathode and a negative end known as the anode. These two terminals are electrically isolated from each other. In between is an electrolyte which allows the flow of electrical charge between the cathode and the anode. Batteries provide direct current, which means the electrons flow in one direction. The electrons want to get back to their source, and they will immediately take any path to achieve that. By placing things such as a lamp or a motor in the circuit, we can force the electrons to do work for us. We can connect batteries in one of two ways, series or parallel. When we connect batteries in series, their voltage is added together, so two 1.5-volt batteries will give us 3 volts. If we connect the batteries in parallel, then we will only get 1.5 volts regardless of how many we connect together. However, this configuration will have a larger capacity, so we can power a device for longer.